Alright, so chapter 7, nomenclature. So nomenclature is just a fancy word for naming. Alright, so naming. So if you want to title these, I forgot a slide to title these. So if you want to title your notes somewhere, it might say Ionic nomenclature. I don't know what the first slide says. But if you want to title these at the top or somewhere on this paper, you might want to title it Nomenclature Chapter 7. And then put naming, because that's what nomenclature means. Naming. And nomenclature is not specific to science. Alright, nomenclature is just a word that means naming. So you could do like the nomenclature of the presidents, where you name the presidents. It's not specific to just science. But for us, we're going to be naming chemical compounds. Okay? So my first slide is not on your paper, okay? Because today we're going to be going over specifically ionic naming. Alright, because we know we have two types of compounds that we've been really learning about, and that's ionic and covalent. Alright, so that's the two types we're going to learn to name. So today we're going to talk about just ionic. Alright, but I want to talk to you about how we're going to break down this unit. Alright, so we're going to learn specifically 5 types. The first 3 are going to deal with ionic. The second 2 are going to deal with covalent. So instead of having one big test that would cover all of it, I'm going to break it up into 2 quizzes. Okay? So I don't have this slide for you, but I just want to show you. So the first 3 types we're going to learn today. Alright, so we're going to learn binary ionic. So you can see that slide on your paper, binary ionic. Then we're going to learn ionic with a transition metal. So then we have that slide on your paper. And then we're going to learn ionic with a polyatomic ion. So we have that slide on your paper. Alright, so those are the 3 types we're going to learn today, which we've talked about all of these things already. Alright, then we're going to practice it. Then we're going to review it. Then we're going to take a 60-point quiz on it. Maybe, what is today? Today's Wednesday, so maybe quiz on Monday. Okay? Alright, then we'll switch into our covalent. So we'll learn how to name covalent. And then along with covalent, we're going to add in acids, which look like covalent compounds, but we'll talk about how acids are different. Alright, then we'll separate it and have another quiz, which will only be 40 points. So together, how much will our quizzes add up to be? 100, and that'll count for your nomenclature test. So we won't actually have a test over all 5 types. Okay, just 2 quizzes, it'll count for a test. Alright? Now, individually, they're not bad, and people will tell you that. It's when you add them in together that they get really confusing and people start to mix up all the rules. So I found that separating them into quizzes helps, but it's rules that you have to remember. Okay? So you got to pay attention. Alright? So let's start with our binary ionic. It's not working well today. Okay, so binary ionic compounds. It should be your first slide. Alright, so what do we know binary means? Binary, 2, right? 2. Alright, so binary ionic is going to be when we have 2 elements. Alright, so 2 elements. And if it's ionic, what are our 2 elements? A metal and a non-metal, right? So we have a metal and non-metal. Alright, so binary ionic. We have a metal and non-metal. Alright, so we're learning how to name it. Alright, nomenclature. How to name these compounds. Alright, so to name it. Alright, so number 1. We're going to name the metal. So we don't ever change the metal's name. We just name it. And we know that when we have our formulas written out, which one always comes first in our formula? The metal or the non-metal? The metal. So we're just gonna name the first one, the metal. Just name it. Alright, and then step number 2, we're going to name the non-metal with the suffix. And where do suffixes go? The beginning or the end? The end. So we're gonna add the suffix "ide," I-D-E. So we're gonna cut the end of the element's name off, and we're gonna add the suffix "ide." So here's a common one that we know. It's table salt, that's the common name, but NaCl. So what's the name of the metal? Sodium. Na is sodium, so we name the metal sodium. And then instead of chlorine, what will it become? Chloride. Sodium chloride. Sodium chloride. Okay? Good with that? Alright. Okay, so let's go through our anions. Alright? And I made it easier on your page, and I didn't put it in my own notes. Perfect. Alright, so we're going to go through all the anions so that you know where does the element's name cut off and where do we add "ide." Alright, so all the nonmetals, because we know anions are nonmetals. Alright, so the first one over there, hydrogen, becomes hydride. Alright, then we jump over to the right. Carbon becomes carbide. Alright, then we have silicone becomes silicide. Nitrogen becomes nitride. Phosphorus becomes phosphide. Arsenic becomes arsenide. Oxygen becomes oxide. Which one does it end with? Next one. Alright, sulfur becomes sulfide. Selenium becomes selenide. Tellurium becomes telluride, which is a third row Kia. Fluorine becomes fluoride. And then chlorine, we already said, becomes chloride. Bromine becomes bromide. Iodine becomes iodide. And the last one, astatine, becomes astatide. So that's all the nonmetals, all of them. So that's where you would cut their name off and add "ide." Yep. All right. Everybody got those?
Yeah.
Okay. All right, so let's do some examples. So Al2S3, Al2S3. Let's see here. Kaden, what would Al2S3 be?
Aluminum. Aluminum sulfide?
Yep, perfect. Aluminum sulfide. Good. Aluminum sulfide. Jacori. Well, we already did this one. We know that's sodium chloride. We already did it. So Jacori, what would SRS be?
Strontium sulfide.
Yep, strontium sulfide. All right, Li3As. Nate, what would that one be?
Lithium arsenide.
Lithium arsenide. Good. Alright, and the last one here, K-I. Arius, what would that one be?
Potassium iodide.
Potassium iodide, perfect. Potassium iodide. Any questions on binary ionic? Pretty simple, right? You're just changing the ending of your nonmetal to I. No questions? Alright. Okay. Now, we have already done this. Like, we literally did it on our last test. But the difference now is that we're given the name instead of me just giving you two elements. So, writing the formulas for ionic compounds. It was the box on the test where you had to cross the charges to get the formula. Now, you're going to be given the name and you have to write the formula. Alright? So, writing formulas for ionic compounds. How is it different? Well, instead of there being an and in the middle, alright, I won't be giving you two elements. It'll actually be the name, so there's no and. Alright, and there's "ide" on the end of our nonmetal instead of the end of the name. Alright, so how do we do it? We are still going to cross charges. Cross charges. Alright, but the good thing now is that it's always going to be written in order. You don't have to worry about, did Miss Dow try to trick me and put the negative one first? You don't have to worry about that. It's always going to be in order for you. Alright, and then reduce subscripts if possible. So if we can reduce our subscripts, we still are going to do that. That doesn't go away. Okay? So my first one here, I only have two things. I need to look up their charges and cross them. So I have aluminum fluoride. Well, what's my first element? Aluminum. And what is aluminum's charge? +3. Alright, what element would fluoride be? Fluorine. Alright, it's just the ending got changed to "ide" when we named it. So this is still fluorine. And what is fluorine's charge? -1. So when I cross that, what is my formula going to be? AlF3. Alright, so the only thing changing here is that the ending of my nonmetal is now an "ide" instead of what it used to be. Okay? So the next one, potassium nitride. What's my first element? Potassium. And what is its charge? +1. Alright, what element is nitride? Nitrogen. And what is its charge? -3. Once I cross those, what's my formula going to be? Yep, K3N. Alright, and the last one, magnesium sulfide. So what's my first element? Magnesium, and what's its charge? +2. What element is sulfide? Sulfur, and what's its charge? -2. What's going to happen to my 2's? They're going to cancel out, so what's my formula going to be? MgS. Perfect. So it's still crossing charges to get the formula. So on your test or quiz, it's not really a test, quiz. The first half, you're going to have the formula. You have to name it, just like we did on the slide before. The second half, you're going to have the name. You have to write the formula. They're basically opposites of each other. Okay? So this part really isn't new, right? We've been crossing charges. The only thing new is that you'll have the name, which we're now learning. Okay?
Yeah.
Alright, we good with this part? Yeah, pull that down if you need to. Good with this part? Alright, so now let's add one more layer to this. Oh, not a Trojan challenge. Not that. See, I used to do this very differently. Still doing it. Alright, are we at this slide now? Yes. Okay. So let's add this in. Hey, Mr. Mahone, do you see the other chemistry teacher in the room? See it right here
Yeah, good
on the
job.
tripod?
Yeah, I see that.
There we go.
Good job.
Alright, so, alright, ionic with, now we're gonna add in the transition metal. Where are the transition metals located?
The middle.
The middle, what groups are the middle?
3 to 12.
3 through 12, okay? So we know that our transition metals are groups, so groups 3 through 12. Now, remember when we talked about the transition metals, it also applied to 2 other elements. What other elements were those? Lead was 1, so Pb, and tin, Sn. Good, Sn and Pb, bottom of group 14. They act like transition metals, okay? So this is still gonna apply to those 2 also. Alright, what do we know about transition metals? What do we know about their charges?
They vary.
They vary. They can have different charges. That's why we can't assign them a set charge. We know they vary. Okay. Alright, so their charges vary. And do the elements have 1 charge? No. What do they have, Nate? Multiple charges? More than 1? 3? 5? They have more than 1 charge, right? So that's why we always had to indicate their charge, okay? So it's the same way here when we name them, all right? We had to, I was always giving you the charge in the last unit, remember? And I was either writing it with the element or I gave it to you as a Roman numeral. Now, I was giving it to you as a Roman numeral to kind of foreshadow how we name them. So when we name them, we write Roman numerals, okay? So charges vary. We need to add that. We also need to add that they can have more than 1 charge. I think that's all we're going to put on that slide because I have another slide. Yes. Yeah. All right. So how to name these? It's not that different from before, okay? So first step, we're still just gonna name our metal, just like we just practiced. So name the metal. We never change our metal's name. We're not gonna ever change calcium to calcite, okay? We're always just gonna name our metal. All right, but the difference now is since those transition metals can have multiple charges, we need to indicate the charge in the name, okay? So we're going to indicate the charge in parentheses, this is it, I. That didn't look right, that's I. In parentheses, in Roman numerals. So indicate the charge in parentheses in Roman numerals. Do you guys still remember your Roman numerals 1 through 6? Everybody still remember those?
No.
No? Okay. So I is 1, 2 I's, 2, 3 I's, 3. Alright, we know V is 5. So I before V, 4. And I after V, 6. All right, and last step, we're going to write the name of the nonmetal with the suffix "-ide". So what is the only difference when we have a transition metal, when we go to name it?
Roman numeral.
The only difference is the Roman numeral, step number 2. That's the only difference, is adding in the charge of the metal in Roman numerals. Now, it's not just gonna be given to you. Remember when I wrote it out 3 different ways last unit? And I said, this way is the hardest way. And we'll get to that next unit. All right, well now we're here, okay? So you're gonna be given the formula, COI2. How do we know the charge of cobalt? We're gonna have to uncross. So now we're to that more difficult part, but we're gonna be practicing this. We're gonna have to uncross our subscripts to figure out what our charge is. And it's not always as simple, let's just uncross. Alright? So when we uncross this, we uncross our 2, that means it's plus 2. But we need to check our iodine. What's our subscript for cobalt right now? 1. So let's check that. Let's uncross this. Always check your nonmetal because it has a set charge. Is iodine -1? Yes. So that's how we know cobalt actually is 2. So cobalt 2 iodide. This part is still the same as what we just did, cobalt iodide. The only difference is now we're adding in that charge in the middle, Roman numeral 2. And we only do this for our transition metals. Only for transition metals. Okay? So let's do some examples. Alright, first one. So flip your paper up. MnCl. Alright, find Mn. Where is it at? It's in group 7. So my thing is when you are looking up when you have your formula, you know it's ionic, look up where your metal is every time. Alright, if it's in group 1 or 2, you don't need to put the charge. Or if it's in group 13, don't put the charge. But if you have a metal that's in groups 3 through 12 or 14 right here, put the charge. Okay? That's when you need to put your charge. So this is in group 7, so we're going to have to put the charge. Alright, so what is the name of Mn? Manganese. Alright, and what's chlorine going to become? Chloride, so we know that part, but we got to find the charge to put right here in the middle. So we're going to uncross. What are my subscripts right now? 1s. So if I uncross, that's +1, this is -1. So check, is chlorine a -1? Yes, so that means manganese charge is 1. So Roman numeral 1. That's best case scenario. We want it to work out that way every time, which half the time it will. Alright, next one, Cu3P. Alright, so find copper. It's in group 11, so we know we gotta put the charge in the name. Alright, so copper. And what's phosphorus gonna become? Phosphide, good. Alright, so now we uncross. So I bring my 3 up here. Alright, and what is my subscript for phosphorus right now? A 1. I bring that over here. Is phosphorus a -3? Yep, so what is my charge for copper? 1. So copper, 1. Alright, next one. Sn. So group 14 metal. Do we need to do this? Yes, we gotta put the Roman numeral. So what is Sn? 10. Alright, so Roman numeral. And then what's oxygen gonna become? Oxide. Alright, right now what are our subscripts? 1s. Okay? So I uncross that. So that's -1, +1. Is oxygen a -1?
No.
No. What is oxygen? A -2. So whatever I do to one, I have to do to the other. So if I multiply my 1 by 2 to get it to its charge, I have to multiply this one by 2. So if this becomes a -2, this becomes a +2. So what happened when I crossed my 2's? They were canceled and reduced to 1s, which is why it became an SNO. So that's why we always gotta check our non-metal. So what is the charge of 10? 2. 10, 2, oxide. Does that make sense? So whatever you have to do to one to get it back to its original charge, you have to also do to your metal. Alright, and the last one, PbS2. Alright, so lead, group 14 metal. So we gotta figure out its charge. So we have lead. What's sulfur gonna become? Sulfide. Alright, if we uncross, we currently have a 1 for lead. So we would uncross, we would get -1 for sulfur and +2 for lead. Is sulfur a -1? No. What is it? -2. So I would have to multiply that by 2. And if I multiply this by 2, I have to multiply this by 2. So this becomes -2. What does lead become? +4. So this would be lead 4 sulfide. Questions on that one? Yes, Jasmine.
What with the lead and tin? Does it have to be the plus or minus 4?
It can be lead and sulfur, or lead and tin are typically +2 or +4. Yep. Any questions on when it's a transition metal? So we still name the metal, we still name the non-metal with the suffix "ide", we just now have to uncross so we can find that charge to put in Roman numerals in the name. Any questions? No? Alright, last time. Let's add in a polyatomic ion, which I think these are the easiest. So polyatomic ions. Alright, I have the same list up here that you have on the back of your periodic table. Alright, how can we identify that a compound includes a polyatomic ion? So I'm going to go to the next slide, which you guys have too, this slide. So these all have polyatomic ions. How do these look different than the ones we've done so far? They have more elements in it, right? The others were binary, which meant 2 elements. Do these only have 2 elements? No. How many do these have at minimum? 3. So we could say that in order to include a polyatomic ion, it has to have at least 3 elements, because our polyatomic ions have 2, and then we're adding it to something else. So a compound with a polyatomic ion has to include at least 3 elements. So it has to have 3 or more elements. So we know that we're not going to be naming 3 things. Okay, that's not going to happen. We're not naming 3 things. Alright, we're only naming 2 things. If it has 3 or more elements, it has a polyatomic ion in it. Alright, so to name a compound with one of these polyatomic ions in it, first you have to find the polyatomic ion, and then step number 2, name it. And never change any part of its name. So we can't change any part of the formula, and we can't change any part of its name. So if you see it, you name it. And that's it. Name it in order. Alright, but we can't ever change any part of a polyatomic ion's name. You just name it. So name it and never change any part of its name. Alright, so first one, KOH. Identify the polyatomic ion. What is it, KO or OH? OH. Alright, so we know our polyatomic ion here is OH. Alright, so we need to name these in order. So we need to name K first. So do we ever change the name of our metal? No, so we just name K. So what is K? Potassium. And then what is OH? Hydroxide. So hydroxide. So the name would be potassium hydroxide. Just name it in order. Alright, next one. Na2SO3. What's the polyatomic ion? Sulfite. Perfect, Jaslyn. SO3 is sulfite. So we're going to name them in order. What is Na? Sodium. So sodium first. And then SO3 we know is sulfite. So sodium sulfite. Now when there's parentheses, it really helps you identify the polyatomic ion. So what is the polyatomic ion in the third one? Ammonium, NH4. So we're going to name that one first this time, ammonium. But this time we have an anion. So what will phosphorus become? Phosphide, because we always change our anion's name when it comes to ionic compounds. So phosphide, ammonium phosphide. All right, next one. Lots of elements here. So what do we have? We have ammonium. What else do we have? And what is that? Acetate. We have two polyatomic ions, so we just name them in order. Ammonium, acetate. All right, and the last one. What polyatomic ion do we have? Hydroxide. So we need to name our metal first, which is what? Iron. Alright, but where's iron at on the periodic table? It's a transition metal, so we need its charge in the name. So this is iron something hydroxide. So we're going to uncross. So what number do I uncross? The 3, right? I'm going to uncross that, so that's +3. And then what's my subscript for iron right now? 1. I'm going to uncross that. Is that hydroxide's charge? -1? Yeah. So that means this is iron what? 3. Iron 3 hydroxide. Iron 3 hydroxide. Any questions on those? So I think the polyatomic ion, in my opinion, are the easiest. It's anytime you have more than 2 elements, just find it. And you always have your polyatomic ion list. On tests, quizzes, assignments, just find it. Find which one you have and name it in order. Okay? Alright, so let's do some examples together. Alright, so the first one, LiBr. Alright, LiBr. So, we got 2 elements here. We know there's no polyatomic ion. Find lithium on your periodic table. Do we need to include the charge? No, because lithium's where? Group 1, right? So we don't need to include the charge, so we're just going to write what? Just lithium. And then Br, bromine, is going to become what? Bromide. Alright, talk with your group about number 2. So at your group, talk with your group about number 2.
Oh yeah.
Yeah, that list that I can hear, that's the same list that's right here.
Just go ahead and pick the best.
But it's just
have to look at that. So you got 3 elements here. So what's the polyatomic ion in it? Do you see a polyatomic ion that starts in K? No? So, do you see one that starts in C? So what's your polyatomic ion? Carbon. So now never mind. Wait till she gets back. Alright, Ahmed, what did your group get?
Second one, potassium carbonate.
Perfect, because we don't have to include the charge because potassium's in group 1. And we have a polyatomic ion, it's carbonate. So potassium carbonate, perfect. Alright, work with your group on number 3, ZrCl2. If you're worked ahead, that's good. But talk to your group about it, because there could be someone in your group struggling.
Number 3, that's a delta.
Alright, Brianna, what did your group get for number 3? Zirconium? Good, because zirconium's a transition metal, so we gotta cross charges. So our 2 comes here, our 1 comes here. We gotta check chlorine. It is -1, so we get zirconium, Roman numeral 2, and then chlorine becomes chloride. And then finish up your number 4 if you haven't yet.
What is the blank? And you will always only have blank names.
2. In the top of your slide, it says you always only have blank names. That's 2. You always only name 2 things. So 2 names. You'll never have 3 names. There will always only be 2. Alright, and Ja'Cory, what did you all get for number 4?
Lead, Roman, like the red lead, Roman numeral 4, sulfate.
Good, because we know we're going to have to put the charge of lead in our name. We uncross. This is +2. This would be -1. But sulfate is a -2. So we would have to multiply this by 2, and we get a 4. So lead, Roman numeral 4, sulfate. Perfect. Questions? Trying to see what the last slide is. Any questions on naming? I don't even know if I have your last slide. Do I? Oh, is this it?
Yes.
No. Is it how those work? No. Okay, I don't think I have your last slide. Alright, your last slide. Alright, so when we do the opposite, when we're writing formulas, like I said, always cross charges. Always. And guess the blank for the next one. Reduce. Reduce subscripts if possible. So for the first one, you know that you always have 2 things. You're looking up their charges and you're going to cross them. So barium. What is barium's charge? +2. So Ba +2. what element would fluorine be? Or, I already told you, dang. Fluoride, sorry, is fluorine. So that's F with what charge? -1. So when I cross those, what do we get? BaF2. Alright, next one. We have chromium 6. What is the charge? 6, right? The charge is, I messed up because I said 4 first, so my bad. Alright, so Cr plus 6. It's giving you the charge right here. Alright, then we have selenide. What element is that? Selenium. And what's selenium's charge? -2. So when I cross that, I get Cr2Se6. Can that be reduced? Yes, what would it be? Se3. CrSe3. Good. Alright, next one. Calcium nitrite. So what is calcium charge? +2. And nitrite. What is nitrite? It's polyatomic ion because it ends in ite, not ide. Gotta be careful there. So what is it? NO2 -1. So be careful with your ites, eights, and ides. Ide is the element. Alright? So when I cross this, what do I get, AJ? Perfect. Parentheses around our polyatomic ion with the 2 outside. Perfect. And the last one, lead 4. So what's my charge of lead? 4. So Pb plus 4. And then sulfate. What's sulfate? SO4 -2. Good. The polyatomic ion. So first I cross it and I get Pb2 SO4 in parentheses with the 4 outside. Can I reduce it? Yes. What reduces? The 4 on the outside and the 2. Can the 4 on the inside of the parentheses reduce?
No.
No. Only our charges can reduce, which is the 2 and the 4 on the outside. The 4 on the inside cannot reduce because then it would no longer be sulfate. So this becomes a 1. This becomes a 2. Any questions on formulas from names or names to formulas? No questions. Ja'Cory, will you stop my video, please?